Good morning. Thanks for being willing to join us for this interview for Engineers Week. We have a lot of student to be engineers who could use some more information on it. So if you would like to begin, tell me your name and your job title.
Hi, my name is Becky Sievers, and I am a lead civil engineer for Army Corps.
What do you do as a lead civil engineer?
My emphasis is in structural engineering, and I work on whatever project is needed at the time, and I write specifications, I do cost estimating, I do the design component of structural analysis that then leads into a full design package to be built for construction.
It sounds like you do many things. Could you tell me about a project or two that you were on that you got to do some design analysis for?
Sure. I recently came over to Army Corps, but I was with Bureau of Reclamation before that, and they deliver water to ag farmers as well as municipalities. At one of their major pumping plants, they have a trash rack system which screens out any kind of floating items in the riverway, allowing water to go through a pumping plant. And there was a crane system there that helped remove all of the debris out of the waterway that needed to have betterment due to seismic or potential for earthquakes, as well as any high wind forces. And so on that project, it was an existing crane that we had to reanalyze and provide additional structural supports for because it was in such a high seismic and earthquake region.
That sounds really cool, especially thinking about earthquakes and wind. Are those things you usually have to think of when you're coming up with structural projects?
Just about every project that I'm aware of, unless you're doing something small inside of a power plant or an existing building that's a standalone structure. So like a pump pedestal, that wouldn't necessarily need to have wind applied to it, but it would still need to be rated for seismic, because the seismic will, or earthquake will have an effect on the entire foundation of the plant itself.
Very interesting. I think we'll come back to a question about testing for seismic later. But first, could you tell me about the design process for structural engineering?
Sure. There's normally a problem given to us by a given client, and they will say that they need to have this thing installed, this item corrected. And so then we will go through the data collection process of what is all of the existing information, what is the existing requirements. A lot of them come from the operations itself. How do they operate this crane? How do the operators get to that area? Sometimes you need to have a truck that will raise them up 20 feet in the air to be able to change out bolts. And so a lot of those things go into the design. When that is all done, and the client, the designers, cost estimators, operations are all on the same page of what the scope is for the project, then we'll go into the design phase. You'll set whatever building code it is at the time, and the building code that we deal with will normally tell us what is allowed, what's not allowed, what kind of stresses are allowed in each member. Then we'll design each feature as needed, and it's designed as a system. So you may design a column, so the vertical member holding up the load, but that column also has weight from a beam. And so all of the loads, they need to make sure that the beam has all the design components it needs, and then all of those are transferred to a column. So as the system as a whole has to meet the building code requirements. And the building code is only the minimum. So if you have any question about a site and you think that there's not enough known about the foundation systems, you may want to have more load resistance or more ability to have higher loads than what you anticipated based off the building code. And from there, you now have your design. It goes into a quality assurance type process to make sure that the designers have caught everything that was originally intended in the scope. You'll have your calculations, your drawings, specifications, and even the cost estimate to make sure that what we anticipate as the cost is what the contractors will likely come around to, because we need to make sure we have enough money to be able to pay for the item. And once it comes out of the quality check review, we'll then make sure that all of the comments have been addressed. Everybody is in agreement of what those comment resolutions are. And then we'll be able to move it on to our contracting, and then they're able to award it to a contractor so that they can build the item. Engineering doesn't stop at the award. They continue working with the contractors throughout what they call closeout. So that's getting to the very last checks to make sure that the contractor has built what the engineering have specified. And if there's any kind of issues that, like, a part is no longer available, what the contractor will ask, well, what can we use instead? Or this is what we propose instead. And so there's a iterative dialogue going on between engineering and the contractor until the complete closeout. And the contractor gives over all information that the operations will need to have to be able to operate a crane or a transformer or some kind of moving part that they will have to go in and do maintenance on.
Quite a very involved process.
It is.
So I'm guessing no project really gets done in under a year.
I have not seen too many being done under a year in the government sector. I have seen them done in under a year in private sector, where a contractor already knows exactly what they need to have built. Say a Starbucks, they know they need to have it built. They will hire an engineer, and a lot of times they already have an existing relationship with that engineer, and they've done many of the same type projects. So they're able to be very efficient with the engineering analysis that's needed and assumptions. That process, the design component to getting to a permit can be done under a year, but it does take a lot of coordination, a lot of decision making, all happening at the same time. But it can happen. It's normally for relatively small projects, though.
Wow. It sounds like a lot of information you have to know to keep track of when you have to do this kind of work. What kind of tools do you use? Do you draw things out, write them down? Do you use mostly computer to do this kind of work?
Each project is different on what type of analysis is required. I do write everything by hand. I am a very thorough note taker. That's how I remember things. I may never have to go back to my notes, but the act of writing them is what kind of puts it in my brain. Once we determine the scope of the project, then that will kind of guide us into what kind of tools we'll need to have. Some tools we can do with Excel. Other tools we need to be able to use a higher computing software. Like there's one called RESA 3D. So that is a finite element analysis. So that's where it takes little bits of pieces of information and applies load on a very small basis to make sure that all of the entire member can withhold that the required load. It just depends on the project. Are we just trying to do like a small slab? If it's a small slab, we can do that in Excel. If we're trying to do a large structure, 2-3-story structure made out of steel and concrete, then we'll need to have a much higher powered analysis software. I use AutoCAD on every project. I use AutoCAD, which is the drafting software for creating the drawings for contractors to build off of. I personally use that in the preliminary design phase. So I do that as my layout of how I expect the plan to go. I will shift things around on there because for me, it's much easier to move those items around on a digital space than to redraw, erase on pen and paper. I started my career in AutoCAD, so I'm very comfortable with being able to move things around there efficiently, and then we can transfer that into the design documents seamlessly.
Mm-hmm. So you talked about moving. It's easier than to write and erase, write and erase. It sounds like you make a lot of designs for every project. Is this true?
Yes. Normally, I've normally been the lead structural engineer on the project and doing some like grading type civil work also. But normally, I'm the one doing getting all the constraints in, and then if there's pieces that I can work on with another engineer in our office, I will be able to give that to them. So if I'm doing high-end 3D analysis, I'll be able to give all of the loads to a more junior engineer for them to be able to do the foundation for me. So then we can work together, and then they learn the how to use the codes, what it is that I'm looking for as the structural engineer, of how the loads are working, what the geometry looks like, how deep it is, how does it affect the cost, and kind of teach them so that they now have a basis to be able to build off for their next designs.
Mm-hmm. Could you tell me the difference between a good design and a great design?
A good design is one that makes sure that all of the code components are there. It takes into consideration various cost components, and it meets the need. A great design is understanding how it will be built, who will be maintaining it, how easy is it for the operations to get in, maintain on a daily basis, where they're not having to move around in awkward positions, put their safety at risk, having to hang off of things by ladders or any kind of safety harnesses that it could have been designed in a different way to make it more safe for the original contractors as well as the operations and also keeping into consideration the various like OSHA requirements for OSHA requirement, there are certain depths that require different safety components or need to have stairs, and keeping those in mind through the entire design process.
Mm-hmm. Mm-hmm. So many things to remember.
Yes.
It sounds like you go through a couple designs. So if I'm building something and maybe my first photo, my first drawing isn't right, that's okay to go back and do it again, right?
Definitely. Just about every project I can think of that I've done is an iterative process. So you'll make your first assumption on what you think it could be. You go through all of the calculations and you may see that, oh, it's not strong enough. So now it's time to go back and reassume some of the components. I've had many of them that it will take, 5, 10, sometimes 15 tries to get that, to get to the most optimal. You can do it where you make your first assumption and it will pass, but it's passing by too much. So then that means that it's no longer economical. The size of the member is too big and you don't need it to be that big. So you can do some cost cutting for your client. Instead of having a beam that weighs 100 pounds per foot, you could drop it down to 85 pounds and save them the cost on the installation methods as well as the raw member size themselves. Every iteration you go, you learned a little bit more from the one before, and it's just getting you closer to the end result.
Mm-hmm. Nice. Earlier, we had talked about, you had mentioned earthquake, seismic testing, wind. I know a lot of us here live in California, so earthquakes are something we think about sometimes. Could you tell me, how do you test your designs for seismicity?
Sure. There are a lot of code prescriptions for it, or a lot of research already done if you are not using a standard building code. So in the case of building a dam, that is not a standard building code. That is not intended for humans to occupy and for them to be inside of on a routine basis. Where a building that, say that you've gone to McDonald's, that building is a building. It's intended to have people in it, and it needs to be safe enough for all occupants to be inside. So the building code will step you through the process of how you rank what they call the importance of that building, what kind of building heights and areas you can have to that size building for what type of category it is. So in the case of McDonald's, that could be a retail shop. Instead of being an office building, because they all have their own allowables for seismic. And it will step you through, the code will step you through the process of the analysis. Each piece will have its own. So for example, a foundation will have its own design parameters that may be different than a hanging sign off the front of the building. And so it will step you through that. And it looks at your specific location in the United States to tell you how much of a seismic risk that building is. And then you would compare all of the loads you get from the seismic to the wind to see which one is the worst case condition, to make sure that your components are built for what could happen at that site.
Sounds like planning for a lot of things that may or may not happen. Could you tell me what qualities you think are important to have in an engineer?
I would say tenacity is a really good one. Not being able to have the most economical or the most correct answer the first time, and being able to chase down what the next step should be, how you could optimize the design, how you could get more inclusion of issues or restraints within a design, and just being able to chase those things down, being resourceful, understanding that the building code is not going to have everything you need in it, but being able to connect with other engineers, being able to connect with other operators and be able to take in their feedback of what it is that they need to perform optimally, or to their best tools that they have to be able to do their job. I would say attention to detail is very, very important, and being able to see the logical progression of the step-by-step process.
Sounds like with some hard work, almost anyone can be an engineer. Do I have to be great at math?
You don't have to be great at math, but math does have a large component of it. I've personally found that by being able to teach myself some programming language, just in Excel, just understanding how to use a lot of their functions in there and combining them all has really helped me a lot. Really being able to trace down an error is huge in being able to build those programs. I do believe that having a strong math background will be helpful, but it's not absolutely necessary. That is easily something that can be learned and taught later on if you just didn't get it in the time that you took it in school. For example, I had taken a physics class early in my college years, and it just wasn't quite sinking in. I then took the class again 3 years later, once I transferred to a university, and everything made so much more sense. It just took a little bit of time for my brain to kind of catch up to all of those theories and understanding of how things move. So it can easily be something that's learned over time.
That's very encouraging for a lot of us. I think I've asked you everything I had planned. So is there anything maybe I didn't ask, maybe some words of encouragement or wisdom that you'd like to pass on to the future generation of engineers?
I would say that my choice to go into structural engineering was a choice that was started in high school. I had never heard of an engineer before. We don't have any engineers in my family, but my high school counselor is the one that said that I had a high aptitude for math and science, and he recommended I went into a drafting class. And so I was in two different drafting classes and absolutely loved it. I didn't necessarily see the connection with math and science at the time, but that one conversation with my high school counselor completely changed my life and direction on where to go. My first job then changed my path a little bit more. Working for a structural engineering firm, I originally thought I wanted to do architecture because that was the class in the AutoCAD class that I had taken in high school that I really liked the most. And by being able to have that job and speaking with the engineers and asking all the questions, because I was not shy with questions. I always wanted to know why. Why are you using welding instead of bolting? Why are you using wood instead of steel? And asking questions in an open atmosphere was incredibly helpful to me deciding where I knew my future would go. And I then found out that structural engineering was a subset of civil engineering, and there's 5 different types of civil engineering that you can do. So that also helped me have a more wide variety of things that I was able to learn at my university. So if you have any opportunities in high school or even in junior high that can kind of help with like career placement, take as many of those classes as you can to see what really speaks to you on what it is that you'd like to do.
Thank you for that. I'd like to thank you for your time today talking to me and the crowd. It's been really inspiring and influential, and I hope that I can work with you in the future, and I look forward to seeing some of your designs that you've made later.
Great. Thank you so much.